Hi, I'm Jasmine, and this is my project on the hydraulic arm. Introduction. This is my problem statement. And description of research I collected. So the hydraulic system was created by a French mathematician and physicist whose name is Blaise Pascal. Hydraulics is a type of power system that involves moving liquids throughout different areas with pressure. It's very easy to use, it's very accurate, and against contrary belief, it generates large amounts of power. Hydraulic systems actually use fewer moving parts compared to mechanical or electrical systems. Hydraulic systems are very similar to pneumatic systems. The only difference is that hydraulic systems use liquids while pneumatic systems use gases. And that's why hydraulic systems generate more energy. Pneumatic systems end up losing a lot of the gas while moving to create force, so it doesn't create as much as hydraulic systems. Now the design process. So this is one of my final sketches that I decided to make my structure on. I have over here, I have a panel with 4 syringes that leads to different parts of the arm. And the pressure from each syringe leads it to do a different thing. So for example, this syringe would open and close the arm. And this would move the whole arm entirely, like right to left. I had to come back to the drawing board because when I started building the first structure that you saw, I ran into a couple of problems. So I was unable to build that structure. So this led me to restarting my whole project. And this is how the new one looks. There's just one syringe that leads it to the arm and it moves it. This is my low fidelity. Again, it goes back to the first sketch that I made. You have your panel here with the 4 syringes and the little arm. This is the description of prototype construction. So I got my cardboard from the packages that actually delivered my supplies. I believe in hindsight it was actually not a smart idea because the cardboard was not as sturdy as I needed it to be, which ended up being the reason why my structure is actually pretty weak. I got the hot glue gun from Mrs. Stiers, which is a family friend. I got the hot glue from Amazon, the skewers from Amazon, super glue I ordered from Amazon as well, and then cardboard cutters from Amazon. So how each part was made. So I first had to figure out how the syringe contraption would sort of be made. So I have 3 different sort of contraptions. Over here we just have a normal short like syringe with tube in the middle to syringe. And over here I have cardboard that separates both of the syringes and sort of keeps it orderly. So I'd have 2 syringes. And here it's pretty long. 2 long syringes. 2 syringes with like a long tube. I ended up going with the 2 syringes with a short tube because that's the most effective way to put water pressure, to get the water pressure easily through, and attach it to the cardboard structure. So this is sort of the cardboard structure with the syringe and tube contraption already attached. I created the cardboard structure by cutting up the dimensions that I needed and then sort of cutting the skewers and then sort of gluing it together. Some parts of the cardboard structure was a bit weak, so I sort of reinforced it with hot glue. And to glue the syringe onto the cardboard, I use a little bit of super glue and some hot glue. So I mainly encountered three problems with construction. Those were overall building reset, the syringe leakage, and part attachment. So I had to start over, as I brought up earlier, with my overall building thing because 4 tubes for the cardboard were weighing down on the cardboard, and my cardboard kept breaking apart and really didn't do the job that it was supposed to do. So I had to cut down to one tube leading between two syringes. And although I reinforced my syringes with like glue to seal the syringes to the tube, I still had a lot of leakages, and I had to figure out the most effective way on how to seal the syringes. And for the last problem, I had a difficulty attaching the syringes to the cardboard because the hot glue wasn't sturdy enough, and I didn't have zip ties at home, and I didn't know how to attach zip ties because my mom recommended, oh, you should just attach zip ties, maybe that would be better, but I didn't really understand like how to do that. So what I did is I used super glue and hot glue. Testing and evaluation. So I was really excited to test out the arm, especially because of how many setbacks I've had. So once I attached the parts, I started to test it. So I started to push the syringe to move the water back and forth. I didn't see the arm moving, so I was really worried. But then I saw that there was water leaking out of one of the syringes, so I had to dismantle the syringe contraption and reinforce the syringe and the tube, so I had to prevent any more leaks happening. I also added some more water in because I saw that there was not enough water for it to move. So for some areas of improvement, I definitely think I can increase the size of the arm. If I were to go back with this project again, I would get some more sturdy cardboard and increase the size, maybe adjust my measurements. And for the second improvement, I'd probably get more proportionate materials. For example, my syringe was really small and compared to my tube. My tube was too wide, and that's why I feel like I ended up with a lot more leakages than I would have ended up with if I had a smaller tube width. And my third area was being more mindful of my space and just like my overall like how I worked. I ended up cutting a lot of my fingers with the cardboard cutters, and I got a second-degree burn from my glue gun on my thumb, which on my right hand, which is a serious setback because it slowed down things for me. Um, and overall, like I was not really aware on where I was like cutting, so I cut like my table as well. So I feel like just being more mindful and figuring out a way how to like split my time a bit better in terms of building, because I feel like I underestimated how much time each thing would take, which led me to stress over a lot of things. And here's the video of my testing. So here you can see that I'm moving it up by pushing the water, and then now I'm going to start to pull the water back, and it's moving the arm down because the weight of the water moves it down. I'm going to do it again. Well, thank you for listening and watching. Um, I really had fun with this project.